Okay, here's some more problems from section 9.4, finding the interval convergence as well as the sum of these series, which are all geometric series on this section. And we have the summation from n equals 0 to infinity, the square root of x over 2 minus 1 to the n. And again, this is a geometric series. It's easy to see that this is the ratio, square root of x over 2 minus 1. So we know it converges when the absolute value of that ratio is less than 1, so we just set that less than 1. And we try to kind of find out where the interval is, so we try to get x in between something. And first of all, we can, this is awkward the way it is, so we'll get out the 2 first, so I'll factor out a 1/2. If I divide out 1 over 2, and I can bring that out in front. And if I divide by 1/2, that I get this out. If I divide 1 by 1/2, I get 2, because 1/2 goes into 2 twice. Or I can think of this as 2 over 2 and then take out the bottom one. And that's less than 1, then I can multiply both sides by 2, so that'd be less than 2. And then I can set my inequality that the square root of x minus 2 will be between negative 2 and positive 2 to remove the absolute value bars. And then I can add 2 to both sides. And I got the square root of x, so I could square both sides. If I square 0, I get 0. If I square 4, I get 16. So this is my interval of convergence 0 to 16. Now, if I wanted to find the radius, we never did have this set up to find the radius. That would be the absolute value of x minus. So what you could do is you could add, or you could subtract 16 from both sides, or subtract 8 from everything. Minus 8, minus 8, minus 8. And then you would have this centered. And then you could go backwards, and you could end up getting at the absolute value of x minus 8 is less than 8. So you could actually see that the radius of convergence is 8. Actually, all you do is take your interval of convergence and go right in the middle, and you get the radius. So the distance from one endpoint to the other point is kind of like the diameter you might want to think of convergence. So you divide that by 2, and you get the radius of convergence. That's all. So hopefully that helps let you see how the interval of convergence is in connection with the radius. It's usually double the radius. Okay? All right. Then if we want to find the sum, remember it's a geometric series, so sum equals, well, a over 1 minus r, but in this case, a is going to be 1, so it's going to be 1 over 1 minus r. And then I can multiply the top and the bottom by 2 to get rid of the bottom fraction here, and I'll also simplify this in both steps. In other words, 1 minus this, and what's a negative times the negative is a positive, so that's 1 plus 1 is 2, so I had 2 minus, well, that's what I did. I just removed the parentheses, so I had 1 minus the square root of x over 2, and the negative times the negative is positive is plus 1, so what's 1 plus 1? 2, so I rewrote it like this to save a step. Okay? And then I multiply the top and the bottom by 2 to get rid of the fraction, because it was the complex fraction, so I got 2 over, and then 4 minus, and then this cancels the square root of x, and that was your sum as a function of x, so it wasn't too bad. Hopefully that makes sense. You can see what I did here. That was the square root of x, that's the same thing as this. Okay, and then number 26, the summation of the natural log to the n. Well, again, you can see that your r is the natural log of x. Okay, we just keep repeating it as a factor. So it's going to converge when the absolute value of r is less than 1, so that's going to converge when the absolute value of the natural log of x is less than 1, or when the natural log of x is between negative 1 and positive 1. Now, we'd like to get a value for x, and the way we can do that is by remembering the fact that e to the natural log of x is x. Okay, the natural log of x is the number that we need to raise e to in order to get x. So that's how I can get x. How am I going to get this? Well, the natural log is an increasing function, and e to the x is also an increasing function. Okay? So there's no discrepancies. They're both always decreasing. They're monotonic decreasing. Okay? So if the natural log of x is between negative 1 and 1, then e to the negative 1, well, I should say then e to the natural log of x will be between e to the negative 1 and e to the 1. Because e is increasing, so since this negative 1 is smaller than the natural log of x, e to the natural log of x will be larger than e to the negative 1. And since 1 is larger than the natural log of x, e to the 1 will be larger than e to the natural log of x. So by the fact that since e is increasing, it implies that, and since the order of these numbers are -1, natural log of x, and 1, then we know the order will be maintained with the e's. Hope that makes sense. Okay? Because e is increasing, so since this number is smaller than that, since 1 is smaller than the natural log of x, e to the 1 will be smaller than e to the natural log of x. And then this is just 1 over e, this is just e, and then this is just x. So now you have your radius of convergence, your interval of convergence. Your radius of convergence is 1. Well, no, it's not 1 because it has to be in the form x minus. So we can find the radius. But anyway, your interval of convergence is 1 over e. 1 over e, comma, e. That's the interval of convergence. Interval of convergence. And then in order to find the radius of convergence, we would have to take this distance and divide it by 2. So we could find the radius. We would just add these up, and we would take this minus this and divide by 2, get the distance. Well, to find the distance, we'd have to take this the distance here and then divide by 2. And we get the radius. But you weren't asked that, thank goodness. But we also want to find the sum. The sum's pretty easy because it's just 1 over 1 minus r in this case, and 1 over 1 minus the natural log of x, and that's all we can do. And we just wanted it as a function of x anyway, so you're good to go on 26. Okay, let's take a look at 27.